We'll try to find domain of the given rational functions here. As you know, rational functions are of the form of p over qx, right? Where qx is not equal to 0, right? Because you can't divide by 0. And that leads to restrictions in the domain. So whatever term makes, or whatever value of x makes the denominator 0 is not allowed in the domain, because you can't divide by 0, right? So that's the whole thing. And so in the given equations, what we need to find is basically what value of x will make denominator 0, right? So that will not be in domain. Rest everything will be a part of domain, because after all, p and q are polynomials, right? So individually they are continuous and they have no restrictions. But since q is in the denominator, it cannot be 0, right? Now, so the first one is, we have these equations in factored form, so we don't really have to do factoring. Sometimes these equations are given in standard form. They are not factored. Now, so basically to find the domain, what we need to do is, we need to find when is the denominator 0. So we say qx plus 5 equals to 0 means that x equals to minus 5, right? And here we have 2x minus 1. So 2x minus 1 equals to 0 means that x is equals to half. So these values, minus 5 and half, will make the denominator 0, correct? So these values cannot be a part of our domain. Do you understand? So therefore, we'll say domain of this function is equals to x belongs to real numbers, where x is not equal to minus 5 and 2 and half, correct? So that is the restriction we're talking about. So whatever makes this 0 is not really allowed. So we say in the domain x plus 5 will make this, x equals to minus 5 will make this factor 0. So that is not allowed. So we say these cannot be 0, right? Or we can start with, well, the denominator cannot be 0. So we can write like this also. And we say, well, x is not equal to half, and we get a domain, right? It's up to you how you see it. Let's look into the next rational function. Here we have given you a factor 3x minus 1 in the numerator as well as in the denominator. Students normally what they do is they cancel them out and then say, well, there is no restriction because it cancelled out. Well, that's a huge mistake. You need to write restrictions before cancelling out the factors, okay? And as such, cancelling out means that instead of a vertical asymptote, we have a hole at that point, correct? In the first expression, we have two vertical asymptotes. That restriction leads to vertical asymptotes. So we have a vertical asymptote at x equals to minus 5 and another one at x equals to half, right? In this case, we don't have a vertical asymptote, but we have another kind of discontinuity. And this discontinuity is at x equals to 1 over 3, because we can say 3x minus 1 should not be equal to 0. That means x should not be equal to 1 over 3, right? As you see, these are common factors, right? So they can be cancelled out. If you cancel them out, what you get? You get 2, right? But here you should write x is not equal to 1 over 3. Otherwise, both are not equivalent, right? 2 times 3x minus 1 divided by 3x minus 1 is not equal to 2. Is equal to 2 if you write the restriction that x is not equal to 1 over 3. Do you understand? That's how it is. So here the domain is, so I'm just writing domain for this function here. We have x belongs to real numbers where x is not equal to 1 over 3, right? How about this function, the third function? Here, we'll try to figure out if x squared plus 4 is equal to 0, right? We say, well, this should not be equal to 0, correct? You can write either way. It is how you see it. So that means that x is not equal to plus and minus. Whenever you do square root, we'll take 4 this side, so it becomes minus 4 and square root of minus 4. Now since minus 4 square root is not a real number, so there is no real restriction here, right? And therefore the function's domain is that x belongs to real numbers. So here we don't have any restrictions, as the denominator cannot be 0, right? This is always positive, x squared, and positive plus positive will give you positive, right? So there won't be any restriction. So these are our domains in the given functions. Now, when we are talking about restrictions, let us also see what kind of discontinuities are we talking about, right? So here the discontinuity was so let's discuss the discontinuities also. It's good time to discuss it, right? Now discontinuity here is that we have vertical asymptote. And the equation of vertical asymptote here is at x equals to minus 5, and the other one is at x equals to half. Is it okay? And about here we have a hole, right? And hole is at x equals to 1 over 3, correct? And its position is 2, right? At 1 over 3, its position is 2. And how about here? Here it is a continuous graph, right? So no discontinuity. Okay, so that is how it is going to be. I hope you understand. And it's important to understand also the type of discontinuity, okay? Thank you.